Hey folks, it's the third episode at the construction site. Today I'll be connecting and welding the containers together, making the most of the process. To teach you all the basics of welding so that you too can weld your containers or anything else for that matter. Spoiler, it's not that complicated. Hi, I'm Julian and this is my container house. I'm 26 years old. I have no do-it-yourself skills, but I set myself the crazy challenge of building an eco-friendly and affordable house. I'm also trying to develop my resilience and live in harmony with nature. I'm filming all of this and putting it on this channel, so subscribe if you want to follow the adventure. Let me start by giving you a quick overview of the project. The goal today is to connect the containers together so that they form a single block. Because even though the containers each weigh 4 tons, over time, with the wind and natural events, they might shift by a few centimeters. So they need to be tied together. To connect them, there are multiple options. The first one, which is certainly the simplest, that would be to buy bridge fittings. They're clamps that tighten International Organization for Standardization corners together, usually sold with containers. Each bridge costs 50 euros, and I would have needed 12 of them to connect all the containers together. That would have been 600, you could have installed them quickly with a small wrench. But I didn't go with that solution. The second solution would be to bolt the containers from the inside. Bruno did that in his container house. He said it was a major inconvenience. So I didn't go with that solution. And the third solution is to weld the containers together. And as you understood, that's what I chose to do. Except the problem, as you can see here, is that the containers are second-hand, so we can't get them to fit perfectly together. There's a 3/1 and 9/16 inches gap. The metals must touch to weld. So what do? We add small metal plates like this to fill the gap, and then we weld the metal plate to connect the containers. All in all, I spent 120 euros on iron, 180 euros on a welding machine, 80 euros on protective gear, and 20 euros on electrodes and consumables. That's it for the welding machine. In total, the project costs 400 euros. You might say I could have paid 600 euros. Going with bridges would have been simpler. I would have had less trouble. But I would need to do welding at several other times during the project. So, that's all the investment I made in the welding machine, in the safety gear. All of that will pay off later. And above all, this is pretty rough welding. It will be hidden by the siding. I'm gonna weld about 30 of these plates, so I can practice, I can make bad welds now, I can learn because it's not super important. Even if they're not all perfect, it'll hold just fine. So yeah, I decided to go with welding. Let's focus on the key point, selecting your welding machine. For this discussion, we'll choose an arc welding machine. Because it's the most common and the easiest to use, it will create an electric arc that emerges from the electrode. It will melt our metal pieces and the electrode to create a molten pool and join our two pieces together. My welding machine is an arc welding machine, an inverter type. And above all, MMA, no worries. Yeah, well, it's always the same thing, MMA. That means there's electronics inside that make it easier to weld. It will stick less, it will bog less, and you won't have to be as precise. Is it made for beginners or? This machine is perfect for average DIYers like me who have never welded before, especially with this type of equipment. It allows you to weld steel from 2 to 10 millimeters thick or even more. I have 6mm pieces, so it's perfect. That's more than enough for me. And then my next welds inside the container will be 2-3 millimeters. I'm never going to reach 10 millimeters of thickness, so it's perfect. Then we'll need to choose the power of our welding machine. Mine is a 160 amp, but to know how many amps you need, you first have to know the thickness of the pieces you want to weld. As you can see on this chart, depending on the thickness, I'll choose an electrode diameter and then a current. On my machine, in my case, I wanted to weld 6mm plates, so I need to use 3.2 electrodes, and I'll need a power between 110 and 140 amps. Be cautious, as welding machines with the same amperage, such as 160 amps, can still differ in their capabilities and performance. 200 euros, or 400, or even 600 euros. So why is there such a big difference in price? Because in a welding machine, the most important thing isn't really the maximum power, it's the duty cycle. It's technical, but once you grasp this, you'll understand the fundamentals of how welding machines operate. On welding machines, you have a little chart that shows you the duty cycle of the machine. At 14%, at 60%, and at 100%, these percentages correspond to a welding time of 10 minutes. What you need to understand is that if I weld at a power of 85 amps, I can use the machine for 60% of 10 minutes, which means 6 minutes. Then it will need to cool down for 4 minutes before I can continue welding. If I weld at 70 amps, I can use the machine for 100% of the time, which is 10 minutes, and it will need 0 minutes to cool down. Basically, you can use it continuously. So you see, at 160 amps, I can weld for 1.4 minutes before I have to let the machine cool down for 8.6 minutes. On the machine I'm using, the Geese 160P, there are little indicators that show you, for example, with a 3.2 electrode, you should normally weld at around 115 amps. So if we refer to our chart, 115 amps, that should allow me to weld for about 3 or 4 minutes, then take breaks of 6 or 7 minutes. It's not written on the chart, but I figure it out. I have to admit, it sort of freaked me out. I was thinking, okay, I'll be able to weld for 3 or 4 minutes, then after that I'll have to wait like an idiot for 6 or 7 minutes for it to cool down. And in the end, it never overheated, never. Why? Because actually, when you're welding, you take breaks all the time. For example, you'll weld 20 centimeters, that'll take you 30 or 40 seconds. The rod in the end has melted. So you have to remove it and put in another one. Then, when the welding is done, you'll have to chip it, clean it, then move your station to the next weld. Actually, you'll be taking breaks all the time and it will have plenty of time to cool down. For example, even I, on my project, welded 3 plates at a time. I tried to optimize and go as fast as possible. It never overheated at any point, because just the fact, as I said, of changing the electrode, moving the machine, checking if my weld was good, and just cleaning it a bit, you're going to take your time. So actually, it will never overheat. In conclusion, the GIS 160P is more than enough, at least for our worksite, to weld up to 10 millimeters of sheet metal. I wouldn't necessarily recommend a cheaper welding machine because the duty cycle will be terrible. And if you need a more expensive welding machine, it means you know what you're doing and you don't need to listen to my advice. So there you go, I'll let you take a look. GIS is a pretty good brand. They're the ones who also make the welding mask, the electrodes, and actually we're going to talk about that now. When using an arc welding machine, electrodes are required consumables. The diameter varies based on the metal being welded, and these electrodes will conduct the electric current, the electric arc. To melt your pieces, the electrode will melt. And after about 20 or 30 centimeters, your electrode will be used up. So you'll have to change it. Things are well made. You have packs of 70, it costs 15 euros for a pack of 70, so it's not a huge budget either. For your information, on my whole construction site, I use about 100, so 2 packs. That's the only consumable you'll need, besides electricity, of course. To weld with an arc, the second consumable we'll need is flat iron to weld the containers together. Let me tell you, flat iron is really hard to find. I visited 5 or 6 stores, but none had any in stock. They have some, but it comes in 1 meter x 2 meter sheets and you have to figure out how to cut it yourself. So I was a bit desperate. I thought, no, I don't want to cut all those sheets. I'm lazy. I then remembered the internet exists and discovered the site Le Roux à Dufer online. And there I ordered sheets that were 10 centimeters wide by 1 meter high, and then I cut them into pieces. Sheets of 33 centimeters to put along the length of the containers. 20 centimeter sheets for Upper International Organization for Standardization Corners and 10 centimeter sheets for Lower International Organization for Standardization Corners. Why did I choose this size? For the International Organization for Standardization Corners, I simply use their size for the container's length. That's my design. The engineering office advised me to put a plate of 25-30 centimeters every 1.5 meters. Because I'm not in a seismic zone, there's no need for much more. My plates were 1 meter, so I decided to cut them into 3 pieces of 33. I could have cut them into 4 pieces of 25. But I told myself that I wasn't sure all my welds would be perfect, so I preferred to weld on 33 centimeters, even if everything wasn't perfect, rather than welding only on 25. For just a few centimeters of difference, it'll cost a few euros more, which doesn't really make much difference. Safety. Be careful. An arc welder isn't extremely complicated to use, it's not super dangerous. But getting hurt would be foolish with months of work remaining. To protect yourself, start with a welder's mask or hood. It's simple, costs around 30 euros, and you just put it on your head like this. And it protects you from the radiation, well, from the spark of the fire. It's the Simple Geese brand. I have nothing special to add. Second thing, hardware stores often sell you leather aprons to protect you from sparks so you don't burn your clothes. I don't support animal exploitation, so buying leather was unthinkable for me. I looked for an alternative, and actually there is one. There's a really simple alternative. It's fireproof cotton. Work overalls are more comfortable and affordable. I use them for my other work. They don't exploit animals. It's all good. I don't have any leather. And it's the same with gloves. At hardware stores, they'll sell you these big welding gloves, really thick ones, and you won't be able to handle anything with them. And the same goes for leather, synthetic leather gloves or fire-resistant cotton gloves. That's more than enough anyway. You're not going to weld your whole hand. It's mostly sparks that might burn you a little, so that's more than enough. Don't forget the reel. Ensure it's completely unwound. It's written on it, 1,100 watts if left rolled up, but 3,200 watts if used. You have to unwind it to prevent the cable from overheating and melting. And the last and most important safety instruction is to support us on TP. Well, yeah, no, but if you don't support us on TP, we can't make videos anymore. So we can't give you safety instructions anymore, and so it becomes dangerous for you. Safety instructions are crucial. Please support us on TP to help us continue making this video series and do reports in other locations. If you can't support us, no worries. Please subscribe, share the video widely, and hit the like button. There you go. You can support us in many different ways. Now that we have the theory, let's move to practice. We're on top of the containers and want to weld plates to connect the two roofs. What we need to do in order to weld is to clean the metal. That means getting back to the original iron, basically removing anything that could interfere with the welding. Paint, rust, grease. You see, for my flat irons, I used a flap disc. I ground the sides so I could weld them. Theoretically, the irons are new, so I wouldn't have needed to use my grinder, but I could have just done it with alcohol. But well, I thought it was just as quick to clean it up like that. And you can clearly see that the iron is much cleaner there than in the middle, and it's the same for the containers. I'm going to have to remove the rust and the paint that I prepare so I can weld. You'll see in the cutaway shots two really clean white surfaces. For that, I'm going to take my grinder and sand a bit to remove it. Here, you see, this is not the right tool at all. Normally, you use a flap disc, but here I have some steel wool thing. Why? Because I can't take it off, it's stuck, so maybe one day, off camera, I'll be able to remove it, I hope. You'll see that even with this, I can still strip it, so it's not an issue. You'll see that with a flap disc, it's easy, and with this, it's just as easy. Generally, preparing our surface is quite simple. We take the small materials, the small protective equipment, the face shield to avoid splashes, and the ear protection. Because it's going to be pretty tough when we do it for a long time. And here we go. Well, that definitely wasn't the right tool. When I manage to get my disc in the mix, it'll be much easier. But you can see that my iron has become very clean. I'm putting my plate on it. Perfect, we have a clean iron and a clean iron on both sides. Let's move on to soldering. Before soldering, we need to set up our soldering station as the clamps aren't connected to it. So, we'll start with our ground clamp, the gray one. We're going to attach it to the positive terminal. It's pretty simple, you just screw it in. Next, our electrode holder clamp, we're going to screw it into the negative terminal. If unsure, refer to the electrode box for instructions on attaching the electrode holder. The goal is to create an electrical circuit, so you need to connect the ground clamp to a conductive spot. Except here I have nothing, I can't attach it to the container. So my technique is to take another flat iron, put it in my clamp and place it on my plate. And here you see we have the current flowing through this cable that comes here and here. Once I put in my electrode, I create a closed circuit so the electricity can flow. You'll see, you'll find your own techniques, but you'll quickly understand that the current needs to flow. And then I set my power to 115 amps here to start welding my piece because I know it's 6 millimeters thick, so it's at 115 amps. It works well. But just before that, I'll cut the power and show you the technique for welding. The goal of welding is to melt a bit of the metal piece here and a bit of the container and to connect them. Weld in the groove between the two pieces. Position your rod at about a 60-degree angle. Actually, well, what does it mean to tilt, really? You'll see when you do it. It's pretty logical. And you need to keep the electrode about 1 millimeter from the surface, so it can create the electric arc. If you're too far down, there's no electric arc, and if you're too close, it will stick. There, just move it, take it off, it comes unstuck, and you can continue welding a little further. When you weld, you'll need to make a small left to right movement, like a snake. That's how you go along. Once on the top piece, once on the bottom piece, once on the top piece, once on the bottom piece. You have to stay long enough on each piece so that it starts to melt and mix together. Soldering isn't just your rod filling the gap, it's the two metals melting and mixing together. And with the rod... Alright, I'm going to weld this piece and I'll explain the rest to you. I forgot to mention, but you need to strike your rod to get it started. To do that, you're gonna rub it to actually activate it, you know? You'll see that right away. There you go, it's done, my weld is finished. Now, I have to wait for it to cool down so I can remove it. The slag has nothing to do with those famous products that exploit animals. What is slag? Actually, it's the little protective layer that's around the electrode. And it will normally settle right above your weld, if you weld properly. And I'll have to break my slag with a chipping hammer and use a brush to remove the last little impurities. So I'm putting my helmet back on to avoid getting any splinters in my eye. And you'll see that if I welded properly, the slag should come off really easily. And if you're struggling to remove it, it usually means the weld isn't great. Let's see. Well, you see, the soldering job is messy because I haven't soldered in several weeks and I need some time to get back in shape. It's not pretty with holes all over it still clearly visible. Where I remove the slag and where the slag remains is that little black layer that I can remove quite easily. It depends on the spots, depending on whether I welded more or less. But these plates are tricky because they're a bit slanted, so the welding is quite complex. But I'll show you other plates that I did much better so you can compare. A nice plate here, there's a cross section of a nice plate, you see it's well welded, and here a messy plate, there are lots of holes in it, it's really not very good. It definitely holds. Structurally speaking, it's not bad, but still, I could have done better, right? There you go. Now that my weld is done, that I've removed the slag well, I went over it with a sander to really get rid of all the slag and make it clean. I'm putting on a little coat of anti-rust paint, and why am I putting on a coat of anti-rust paint? In the cross section, you'll notice rust forms quickly without applying anti-rust paint. So I'm applying a coat of it now. I welded about 30 plates like this in total. That's 8 meters of weld. So even if all my welds aren't perfect, according to my structural engineering office, I'm telling you it's going to hold. Remember, there will also be the framework on the roof. Wooden cladding all around will hold the house together and tie it together. I also welded the containers to the helical piles to prevent them from moving off the foundations. We're not in a seismic zone. So there you go, I got a lot of practice and learned how to weld. That will be useful for the rest of my construction project. And I hope I managed to teach you at least the basics of welding. If that's true, subscribe, share the video and support us on TP, it's crucial. And if you think I forgot something, or if you need more details on other points, feel free to come to the comments section. I'll definitely add more information. In the description, I'll put the link to the welding machine, to the safety gear, and to the charts that explain what size electrode you need for what size metal. I'll put plenty of information in the description for you. Continue the discussion in the comments. And I'll see you in 2 weeks for the next part of the project. If everything goes well, it'll be the cutting. We'll cut the containers and get a glimpse of the space I'll have for my house. Thank you for watching this video until the end, and see you next time. This was Julian.